This video investigates the ambiguous case of the law of sines. We may have two possible triangles whenever we're given two sides of a triangle and an angle opposite a side. In other words, we're not given an angle inside of those two given sides. We're given an angle outside of the two sides. So we might have two triangles if the height of the triangle is less than the two given side lengths. Okay, and normally we're not told anything about the height of a triangle, so we need to investigate the ambiguous case, whether it exists or not, on our own. So two possible triangles may exist. We may have a triangle where we're given side B, side A, and angle A. We know this, and angle B might be acute, or we could have the case where, given the same side lengths and the same angle measure, that looks like a 90-degree triangle, sorry about that, this angle right here is obtuse. Angle B could possibly be obtuse. So that's what we need to discover, and that can happen, again, only when we're given side-side angle not inside of the two sides given. Okay, so let's look at this triangle ABC that has a side length 12 feet, side B is 15 feet, and angle A is 49 degrees. Okay, so let's draw it. 49-degree angle, something like that. And I want to draw a triangle that, remember, our drawings aren't always, accurate totally, but I would like to try to draw this so that side B looks a little shorter than side A. So here's angle A, here's angle B. We don't know angle C, and we don't know side C. So, but we can find out by the law of sines, we can find out angle B. So if I'm looking for the angle, I'm going to put the sine, having trouble with my stylus, sine of 49 degrees is to 12 as the sine of angle B is to 15 degrees. And when we do cross multiply and divide by 12, we find out that the sine of angle B rounded is equal to 0.9434. And so then I'm going to do the inverse sine, because that's obviously not an angle measure, that's our sine value of angle B equals B. And so I find out then that angle B equals 70.628 degrees. Okay, so now I know angle A, I know angle B, and so to find C, angle C, I'm going to do 180 degrees minus 49 degrees plus 70.628 degrees, and I find out that angle C is 60.372 degrees. So now we want to find side C. So we will base it on what we know. We want to find side C is, the unknown is the side length, so in this case I'm going to put 12 on the top for side A is to the sine of 49 degrees, that's our angle A, as the side C is to the sine of angle C, which is 60.372 degrees. Okay, and when I do the proper calculation on that, I find out that side C is 13.821 feet. Okay, so let's check this for reasonableness. Let's line up all our facts that we've discovered. And we know that angle A is 49 degrees. Angle B we found was 70.628 degrees, and then we said therefore angle C must be 60.372 degrees. Now let's compare with the sides. Side A is 12 feet, side B is 15 feet, and we calculated that side C must be 13.821 feet. And let's check this for reasonableness. Let's see. Angle A is our smallest angle. Side A is our smallest side. So that works. We like that logic. Okay. Angle B is our largest angle. Side B is our longest side. So there we go. And then our side angle C is our medium angle. Side C is our medium side. So it is reasonable. It checks. Yay. We like that. Okay, but we were given side angle. And it's possible that angle B could be obtuse. So let's look at angle B and discover, can it be an obtuse angle? 70.628 is an acute angle. Its supplement then would be 109.372 degrees. So possibly angle B is that. Okay, so, but we already know for a fact that angle A is 49 degrees. So, if we subtract the sum of both of those angles from 180 degrees, do we have enough left over to actually make another angle C? Sometimes we won't. Sometimes the sum of the angle A and angle B might be greater than 180, and then right there we can stop. We know we don't have the ambiguous case. So angle C, in this case, could be possibly 21.628 degrees. So it seems reasonable that so far the ambiguous case may be occurring. Okay, so let's find what side C would be if angle B is obtuse. Okay, so here we go. So still, again, we'll base it on what we know. 12 is to the sine of 49 degrees, as C is to the sine of 21.628 degrees. And if that's the case, doing our calculation, we find out that side C is 5.860 feet. Now, so we have to line everything up again and do a reasonableness check. Is this reasonable? Okay, so line it all up again. I'll do this in black this time. Angle A, we were given, is 49 degrees, so that has to stay that. Angle B this time we're saying is obtuse at 109.372 degrees, which forces angle C to be 21.628 degrees. So side A still is 12, side B has to be 15, but now side C is 5.860 feet. These are all feet. Okay, reasonableness test. This time, smallest angle, smallest side. Largest angle, largest side, medium angle, medium side. So what we came to then is two possibilities that look like this. We have possibly this scenario, 15, 12, and 13.8, A, B, C with the appropriate angle measures, or this, 15 is the longest, this guy's the shortest, and this guy's the medium now. So this is 12, 15, and 5.86. Okay, so those are two possibilities that could happen with these facts. Okay, so in summary, to summarize, if we're given side-side angle, that's the only scenario where one of our angles may be acute or obtuse. And what actually happens there is, in that scenario, it turns out that our height is less than our two given sides. Okay, and so this, it's actually side C, an angle C that we don't know. So this is side A, side B, B, and A. And so actually in general, it's side A that could either be on the acute, angle B is acute, or side A could sort of flip in there and cause angle B to be obtuse. Okay, so we just have to, there's no escaping it, we just crank through the calculations and see if it's a possibility. And if it is, then we have two possible triangles. Thanks for listening.